Hello, Morningstar. What's up? This video is just going to be an explanation of the ledge system. I think I'm not going to be explaining everything from scratch because that's going to be very tiring. I think the video is going to be much more didactic. I think that's the word. I think the whole tutorial, the whole purpose of people to watch the tutorial is just to learn what's just to learn how something works, instead of just following a tutorial, right? So I think it's going to be a lot more, how can I say this? It's going to be a lot more, it's going to be a lot better for you guys to understand how I've done things and go through each part. And then I can explain you guys how each part works instead of just doing everything from scratch, which is going to take a lot of time. I'm not sure if that makes sense. Okay. So yeah, let's go. So this video is going to also be recorded into my... I'm going to also use this video for my tutorial. After this live stream, I'm going to edit this video. So this is going to be a tutorial video that is going to be used for posting on my YouTube video, if that makes sense. So I'm just going to be explaining you guys how everything works. Code. I'm going to explain you guys the code part by part. So the first thing you need to do here for the code, for making the ledge system, is going to go to Edit, Project Settings. So the first thing we're going to do here is just to prepare the collision settings. Let me just get this window here. Hold on. Is going to go to Edit. All right. Turn on my AC. All right, so this tutorial is going to be for the ones that wants to make a ledge system tutorial. For those who wants to make a ledge system like this one, it's a very much advanced ledge system. As you can see, the character can climb up, climb down, left, right, diagonally. And it doesn't really matter if you put the ledges misaligned with each other. So as you can see, if I do this, or if I do something like this, the character is always going to calculate what's the best distance and animation he should be playing. And later, of course, you can expand the system later with your needs. So the first thing you're going to do is prepare the collision settings for the ledge stripes, because the ledge stripes are the ones that makes the character to identify in the code how the character should position itself on the ledge, like which angle he should face, and it determines the location of where the ledge is. So let's say, for example, if I would place the ledge like right over here. Let me just disable the hidden option in here. So if I would press on play, and if that ledge would be far away from where it is, and if I press on play, as you can see, the character would be flying on the air. So the ledge stripe is pretty much you should place the ledge stripe exactly at the location of where the ledge is. so that you can make sure that you don't have any bugs like this of the character flying in the air or be too much to the left or right or up or down. Doesn't matter. Morningstar said, after I switched the climb up animation to the updated version, I got some bugs with the timeline. Could you show us how yours look? Let me see. Mine looks normal. Pretty much normal. Yeah, we can check that out later because right now we're doing the tutorial for the ledge climbing system. So as I was saying, we need to prepare the collision settings for the ledge stripe itself because it requires pretty much a specific unique setting for the ledge stripe. So what you're going to do in your project, of course you can follow this tutorial without, you don't really need to necessarily have this project to follow the tutorial. You can follow the tutorial with just the gas project, and also you need to have those animations in here in place, which is the climb ledge animation pack. You can get that pack from the marketplace. So here's the action adventure ledge climbing pack. I'm going to let this pack in the description down below so that you can access it. So here you can just go ahead and add your project, and you're going to have those animations in place. I think I can make a separate video of how to retarget the animations and everything. I think that's going to be a lot more easier to understand, at least just that. So to prepare the ledge stripe collisions, we're going to go to Edit, go to Project Settings, and go to Collision. And here we're going to add a new object channel. We're going to name it to be Ledge. And here in the default response, we're going to click on Ignore and click on Accept. Mine in here, the default response is set to block, but I should set it to be Ignore. So after done that, that's pretty much all you got to do. Now you're going to, of course, do a little bit of level design in here. You're going to get a shape. You're going to get a cube. So we're just going to make a wall where the character is going to attach himself, and then we're going to make a wall and then the ledge stripe, the ledge and the ledge stripes. So the wall is something like this, as you can see, where we have the ledges. Those are the mini blocks that we add to make the ledge. So we're just going to make a simple wall. Let me just make the character to go over here. Oops. So this is the wall that the character is going to attach to. And we can get a material in here. Let's see, maybe this one. So just put that in there, just drag and drop it. Now we're going to make the ledges, right? So we're going to just duplicate this and do this. So if you have the snapping effect, you can just disable these options in here. Just let them all disabled. Just enable this one because this is the rotation. It gives you the exact precision rotation values when you rotate the object. So I like to have the options to be turned on. Now I'm just going to make the ledge stripes in here. Well, this is actually the ledge. Now we're going to make the ledge stripes, which is just going to be by duplicating it. And I like to choose a different material for the ledge stripes. Maybe red would work. I think that's good enough. Something like this. All right, so after we made the ledge stripe, we're going to go down to the collision, to its collision settings. So here on collision presets, you're going to go to custom. And here for the object type, you're going to select ledge. You're going to click here on ignore for ignoring all the other channels. Just enable the visibility so that the trace can detect the ledge stripe. And here for the collision enabled is going to be for query only, because I only want the query to work to detect the ledge stripe. But I don't want to have any type of physics on the ledge stripe because that's not really needed. So after that, you can just duplicate this. Let me just make this a little bit smaller. I think it makes more sense. So you can just duplicate this after that. So again, it doesn't really need to be perfectly aligned with each other, but there is a certain distance that you can place them so that the ledge system can work perfectly. So I think at that distance, it works good. All right, so the first thing you're going to do, I'm just going to explain you this code part here, I think first, or maybe we could go to the ledge system graph, which will have this, this code. Yeah, I guess we can go for the attachment part first, and then we can go to the ledge movement navigation later. I think this is the easier part to go through and explain everything, how everything works. All right, so here when you press F, as you can see, we have a boolean that tells pretty much if the character can attach to the ledge or not. Now you can make this boolean, of course, because without F, as you can see, nothing happens. Let me just try to debug this first. So you're going to create a new boolean called CanAttachToLedge. And the default value is going to always be true because the character is always going to be able to attach to the ledge, unless you have like maybe you're swimming, so the character so this variable could just be set to be off if the character is swimming or doing any other action that won't make the character to be available to attach to the ledge. So you can always add this boolean in here. So you're going to create a new variable, call it to be CanAttachToLedge. So if the character can attach to the ledge, then we're going to choose and pretty much check if the character is already climbing on the ledge. By default, this variable is going to be false. So if the character is not, I'll just disconnect this one. So if the character is not already climbing on the ledge, as you can see, it's going to go to false, and then we're going to run the attach code. Now, if the character is already on the ledge, we're going to run the detach code so that we can use the F key just both for attaching the character and detaching the character from the ledge. So once you attach the character on the ledge, we can just press the same key, which is F, to detach the character from the ledge. So here we check, we're going to have another input. We're going to have another boolean for managing inputs, so that if that boolean is true, we can basically run other codes for inputs, such as climbing, jumping, crouching, all those other things. And that pretty much prevents other bugs. So I think it's good to have that CanProcessInput variable in here, so that it pretty much checks if the player can move, can do actions with the input, such as crouch, jump, attach to ledge, blah, blah, blah. So it pretty much verifies if the player is allowed to input any key. All right, so if the character can receive any inputs from the player, we're going to go for the next step, which is spawning the hang trace attachment. So if you don't have that, as you can see, if you press F, we just run the capsule trace, of course, but nothing happens later. So it pretty much performs a trace to detect a valid ledge in front of the character. So if a ledge is hit, we store the hit result for further attachment logic. So as you can see, we just run a capsule trace for objects. You can easily get it from this capsule trace for objects. Now we have two, which is multi-capsule trace for objects and capsule trace. So just be sure to select the first one. The radius here is going to be 37. This is the value that I found the best. I think it's pretty much almost the same as the capsule of the character, almost the same radius. The half height is going to be 74. But of course, you can always change the radius and the height of the capsule to better, fit your needs. Maybe you have like a bigger character with a bigger capsule. You can always change. Or maybe if you have like a smaller character, you can always change the radius and the half height, whatever makes sense for you. So yeah, these are the values that I found the best. There's not much things to talk about this. The start and end positions are pretty important because it pretty much decides where the trace should start and where it should end. It works like a line trace, but as you can see, it spawns two capsule traces, but it's just one. It's because it's spawning I'm not sure how to explain this, but the capsule trace, it has a start point and an end point. And then you can pretty much define what are these points, where the capsule is going to start and where it's going to end. You can also edit how much forward the capsule is going to be from the character. Now, skipping this one, we can go to the object types in here. So this is very important because it pretty much tells you which kind of object you want to detect. So if you just specify the ledge to be in here, the capsule trace is only going to detect the ledge and not other objects. So if you want to detect, like for example, the word static, the trace is only going to detect the word static object channels. So as you can see, it's going to detect this one, the word static objects. So as I want the capsule to only detect the ledge type of object in here, you just got to make sure that the ledge collision settings is set to be ledge, so for the object type. So the capsule can only detect that object type, such as ledge. So all you got to do is go from here, object types, and make array, and click on ledge. So you can select the ledge for the capsule to detect. Now in here for the draw debug type, as we're only running it once, we're not running in the event tick, we're going to choose for duration. So the capsule disappears after 3 seconds, but you can also change it to disappear after 10 seconds. So as you can see, if you click on F, it's going to disappear after 10 seconds. You can count it. And you can also choose the trace color, the trace hit color. If the trace hits an object, as you can see, it turns blue in this case. But you can choose whatever color you want. So I usually do for duration for this one. And the seconds is 3 seconds. And ignore itself, ignore the character, because the capsule cannot identify, it's not going to be running for, I don't want the capsule to identify, to trace against myself. So now here for the calculation, we basically do a calculation to position where the trace should be at. So all I'm doing here is just specifically telling the engine that I want the capsule to be a little bit forward based from my location, from the location of the character. And I want the end position to be a little bit backwards, or I can choose vice versa. So if I choose here for the start location to be maybe, so the forward offset is here, like 16. If you choose it to be 50, as you can see, the capsule is going to be too much forward. And you can also change these values to see which one works the best. The start also has a offset that puts a little bit up. We can also change this value here. So if you put like 50, as you can see, if you press F, as you can see, it's going to be a little bit up. And that's pretty much it. Now here on the output result is the structure that pretty much tells everything, like the location of where the capsule has hit the object, the impact point, which is I think almost the same thing, the impact thermal, what actor was being hit. If it's a component, it pretty much tells you the component information. If it was a skeletal mesh that was hit, it pretty much tells you the bone name and the distance related to the character and so forth. So we're going to just promote it to a variable so that we can use it later. And we're going to also use this information later to calculate the angle that the character should face at, which location the character should be attached to. And so here in the return value, it pretty much tells if the capsule trace has hit something, it tells you if it has hit. So if the capsule trace hits something, this Boolean variable here is going to be true, is going to return true. If it didn't hit something, it's going to return false. And then I'm going to pass this information to be read in here. So we're going to check if the trace did hit a ledge. So if it didn't hit a ledge, we're going to notify the character that did hit trace first attachment should be false. So if the trace has hit something, we're going to go to the next phase, which is just going to be updating some values. As you can see right over here. So this is just going to be updating some values. So after this, if the trace has hit something, it has hit the ledge, we can just prepare the character's movement, and we can just basically update some values for making the character to attach. Is series over? What series? Yeah, I think it is for the ledge climbing system. Now, of course, I'm going to still make changes for especially for premium members from the ones that are subscribed to my Patreon. I'm going to make the changes for correcting bugs, improving the system more, and having more updates to basically make the system to be perfect. Why Boss Gamer YouTube, keep posting video. You are very helpful to us and educating people. Great indeed, buddy. No problem. Appreciate it. So in here, we're going to update some values, some states. So as you can see, we can disable the CanAttachToLedge so that the character is not going to be able to attach to the ledge anymore, as he is already attaching it. So CanProcessInput is going to be false. Now here we're going to prepare the character movement. We're going to set the character movement mode to be flying And at the beginning, when I was learning Unreal, I was wondering why we would set the character to be flying to play a animation montage. So the reason why is because the character is going to be in the air. So we need to basically set up the settings, the necessary settings for the character to be in the air. Because if you would set to be, for example, walking, and the character wouldn't behave appropriately. So for example, here, if you would attach to the ledge, as you can see, if I try to make the character to go into one direction, the character would not just move, would just not move, right? Yeah, it's telling that there is no tags in here. Let me just try this other one. That's why we're having some bugs. So as you can see, I try to move, but it doesn't happen. So the only movement mode that you can set so that it can work is the flying mode. If you set it to falling, it's not going to work. As you can see, the character is going to fall into the ground. So the best option is going to be the flying one. Here, I like to make the stop movement immediately to be in here so that the character does not slide off immediately when we attach to the ledge, and it makes the movement more precise. So the max fly speed is also it also prevents the character from sliding off the ledge. We set the mesh and the capsule component of the character to be no collision, because sometimes the character might not have a especially when you do corners, the character might require a little bit for the capsule to enter, overlap the box, or if you have any other object that is going to be interfering, that could cause a little bit of bugs, so the character wouldn't be 100%. It wouldn't be that much precise for the character to calculate where he needs to be at. So setting the mesh and the capsule component of the character to no collision is going to prevent bugs that could prevent the character from doing its action of moving from one ledge to the other. Here I like to set the character movement, a rotation movement, to be facing where the location of where the player moves the character. Because if I move the character like this, and if the character is I think that could change a little bit. Oh no, my voice is bad. I think this option is not, it doesn't make that much difference. But it pretty much, I think it pretty much prevents bugs. It helps to prevent some bugs that could happen when the character is not facing a certain direction. I'm not sure how to explain this one. But I think it doesn't make a difference when if you turn it to be true or off in here. So here we update some values, and here we play the ledge catch animation. Now in this part, you need to have the retargeted animation already. Now if you don't know how to retarget the animation when you first download the pack, I'm gonna also make a separate video for you guys to watch it. So this is the animation. As you can see, it's called leap, entry to climb, hang idle montage. And here for playing the montage, we need to specify a slot name that is called LedgeSlot. So when you first create the montage, it's going to be assigned to a default slot. And the reason why we have different slots is because we can choose which specific slot in the animation blueprint you want to execute. So if I were just to select the default slot, the character wouldn't be able to play that montage. As you can see, it's actually playing that montage, but it's not being executed it's not being shown in the front end. But if I select the LedgeSlot, the character is going to be able to execute that montage perfectly. And that comes from here. If you want to make a new LedgeSlot, which you have to do, we're going to go to the window. If you don't have this tab in here called Animation Slot Manager, we're going to go to Window and click here on the Animation Slot Manager. So here we're going to add a new slot. Let's say, I don't know, upper body. So here you can choose now the upper body slot. So all you gotta do is just choose to have the ledge slot in here and select it and assign it through here. So after you've done that, you're going to prepare the slots like this. I think this one is not really needed, the full body slot. Yeah, this is going to be a little bit complicated to explain as well. Let me just see what we have here. So after the pose history, you're going to save a new cached pose. You're going to name it to be such as base locomotion or maybe base motion matching. And then here we're going to create a new state machine. So ledge state machine. I think this one I'm going to have to do it from scratch, so it's better to understand. So in here, we're going to, inside that state machine, we're going to use the cache called base motion matching. So we're going to cut this. And then from here, from the entry, we're going to add a new state called base motion matching. And then here you're going to just paste the use cached pose, or you can just retrieve it from here. So use cached pose, base motion matching. It's the same thing. All right, after you've done that, you're going to plug in a new state from the base and add a new state. And here you're going to choose ledge, I don't know, ledge locomotion, doesn't matter, ledge movement, ledge state. And from here, we're going to basically retrieve the information if the character is already climbing a ledge or not. So we're going to go to the ledge state machine. And here, for the transition from going to base motion matching to ledge state, we're going to get the property axis. We're going to go to the sandbox character. Where is it? Here. We're going to go to the sandbox character and we're going to search for already climbing ledge. So we're going to connect it to here. I'm going to copy this boolean so that I can add in here as well. I'm also going to have the blend poses by Bool, which is just going to be able to serve it to be just switch. So if the character is in the climbing state, this one should be going to true. And if it's not, we should use the base locomotion, base motion matching. Now the true blend time and false blend time should remain to be 0.1. I'm going to explain these values later. And before the ledge state machine, we're going to get the slot, the slot default slot, so that we can change it here to LedgeSlot. So that's what's going to allow the character to play the LedgeSlot animation montages. After that, you can just click here on execute the output pose after that. So now the character is running back the default pose of the motion matching. And as you can see, if the character is not climbing the ledge, it's going to be false. So it's going to execute the base motion matching, which is this one. So if you press on play, as you can see, well, now the character is going to be able to use the normal motion matching. And if he attaches to the ledge, as you can see, the animation is going to be playing. So as you can see right now, the character is on the A pose. And the reason why is because when you execute a state that doesn't have any animation, as you can see, the character plays the animation montage because we're using the LedgeSlot, the correct LedgeSlot, which should be set in there. And we're using the correct LedgeSlot in here. So as soon as this variable is set to be true, we execute this ledge state machine. We execute the LedgeSlot. We allow the character to play animations that are animation montages that have the slot set to be LedgeSlot as it is in this one right here. And then we can play the animation. So if you play, as you can see, but now here on the state machine, on the ledge state, as you can see, we don't have any animation. So that's why the character is on the A pose. So if you don't have any animation here, the character is going to be on the A pose. Now all you gotta do is just going to go and search for the hang idle. I think it's this one. It doesn't need to be a animation montage. Even if you try to get an animation montage, it cannot be. It has to be an animation sequence player. Animation sequence. So all you gotta do now is just connect into here. If you compile, save, and press play, now that animation, that ledge idle animation is going to be playing. But of course, this animation here is a loop animation. It's an animation that keeps looping because it's an idle animation. So if you press play and then just, as you can see now, the loop animation is going to be going. And if you don't, as you can see, the loop animation just stopped. The animation just stopped playing, and the reason why is because we haven't specified here to loop the animation. So we can just have the option to be true so that the animation can play and loop and keep looping. Yeah, so the animation should loop because that's an idle animation. And I think that's all you gotta do in here. Of course, you can change the play rate and how fast the loop animation plays. You can change it to be like 2. So the character is going to be very... It's going to look funny. You can change some settings in here if you want to. You can change the start position, blah, blah, blah. But that's pretty much all we gotta do in here. I've decided to make this part from scratch so that you can understand how it works. Because some nodes that you can get, it requires a specific way to get the informations. Yeah, that's pretty much it. I'm just going to delete this part because I don't need it. So that's how you should set up the code part in the animation blueprint. That's pretty much all you need to do in the animation blueprint. We don't need to touch it afterwards. After you've done this, you don't even need to touch this part of the code in here. You can just let it intact. Now here we play the ledge sketch animation. Of course, we're going to go through here and go like play montage, the first one. And then here we're going to select the skeletal mesh. We're going to just drag and drop it into here. And then here we're going to select the montage to play. So just remember, we gotta get the entry leap, entry hang idle. So just select the animation montage to play in here. And that's pretty much all you gotta do. All right. We still have a lot to go through. So here we disable all movement inputs. Because if we don't, what happens? So yeah, this happens. So if you're on the ledge, for example, here, and you press C to crouch the character, when you drop from the ledge, as you can see, the character is just going to immediately start crouching because you've set the character state to be on that state when he was attached to the ledge. So if you want to prevent that, you can just click here on the set this variable to be false, so that even if you are on the ledge and press C and then just drop, yeah, the character can still do the action. Let me just see. I think there is a variable missing here in the crouch input. So we're going to just get a branch. So get the CanProcessInput. So if the character can process input, it's going to go to branch, and then it's going to check if the character is falling, blah, blah, blah. So now, if I'm on the ledge and press C, yeah, I'm not sure. I think there is a glitch in the matrix. Let me see. And we set this variable to be set to be true, set to be false twice. I think twice. So we don't need this variable here. Yeah, anyways, we don't need that variable in there. It's not really necessary. All right, so here we disable this modes, not glitch the ledge movement. This is for the gas project. Now, if you're running the third-person template project, you don't really need to do this, but of course you're gonna have to disable some settings. So here, what I want to do is just disable the wants to strafe, and disable the strafe mode if the character is on the strafe mode, and disable the aiming mode. So if you don't run this, let's see what happens. So as you can see, the character is going to be strafing. And we can press to strafe, as you can see. So if you compile, save, and attach the ledge, as you can see, the character is not going to be strafing. So that's why it is for. That's what this is for. Now for the next thing we're going to check is if the character did hit the trace. I think this is not really needed because we already check it here. But yeah, this is not really needed, but I like to have a secondary prevention. Here we save the initial ledge angle when first attaching to a ledge. Now that's very important because you want to know which angle the character is going to attach. So for example here, if you take a look at the tags, if you go here to tag, and as you can see here is 0. Now if this tag, let me just get this slide to be in here. Yeah, let's just get this one. So if the first ledge, yeah, we can do it with this one right here. Let's just put this ledge away just to test. So if the tag in here on the ledge is like set to be 90, for example, instead of 0, then the character is going to rotate to that direction, the 90-degree angle. So if it is set to be negative 90 degrees, and if we attach it to that ledge, as you can see, the character is going to face that direction. Now, of course, there is a way to set the tags automatically through the code, but I'm not sure if you guys really need it. Karen Thomason said, are you also going to make the tutorial for this? Like one video, not all your live streams? Yeah, I'm going to make a video. Actually, this live stream is going to be the video itself that is going to be on YouTube. What I'm doing right now is just making the live stream at the same time recording the video, so that later I can cut the video and show only the parts that matters. So I'm basically going to take this video and then just cut the parts, do some editing, put up some subtitles, and publish it later. So here, if you set to be negative 90, as you can see, the character is going to aim to the left. So maybe 180. So that's pretty much going to decide where the character should face at. Of course, there's a way to make this automatically, but it's all going to depend on you guys. If you guys want it, if you guys really want it, I can make a tutorial for this, for making it to be automatically. There is a way to do that. So yeah, you should just place the number, the rotation that the character should face at in the tag, so that the character can perfectly align itself and face the right direction. So let's say you make a ledge for this side right here, a 90 degree. So as you can see, if you just use the same tag, why I cannot? Oh, there we go. If I use the same tag, the character is not going to be correct on the ledge. But if I use negative 90, as you can see now, the character is correct. It's correctly attached on the ledge. Hey, I'm new here. What are you up to? Yeah, I'm just doing the tutorial for the... Well, actually, I'm explaining how you can make the ledge system. Basically, what I'm doing here is just basically explaining the code and the solutions I found for making the code. Yeah, basically, what I'm doing here is just basically... Why am I saying basically all the time? So what I'm doing here is just explaining the code, the whole code for the ledge system, the basic one. Hi, I recently opened your project with the weapon system, and I noticed you use an event tick for the widget. Is this a temporary solution? Yes. After I finish with the ledge system, I'm going to continue with the weapon system from the live streams. I'm going to continue working on that one. I think most people are more interested on the weapon system other than the ledge system. Now, of course, I think the ledge system is much more well made, but it's not that much interested. It's not that much interesting for most people, I think. Yeah, basically, essentially. Well, basically, yeah, basically. All right, basically. So if you just keep that part from the code, and then you try to attach on the ledge, the character is not going to be able to read like which orientation he should be facing at. So in here on this code, we save the initial ledge angle when first attaching to a ledge. So here we create a float that we can store which rotation the character should face at on the ledge. And in the code, in the collapsed graph, we get the ledge angle by getting the hang trace. So that's why I told you to promote the result of the capsule trace, the hit structure result, so that we can use it later. So we're going to use it for getting the ledge angle based from the tag that we assigned to it. So we get the hang trace. So it pretty much saves the detected ledge angle when the first time that the character attaches, used for the later calculations and consistent ledge alignment. So if you don't have this code in here, the character won't know which rotation he should face at. Now, I've already tried different methods like getting the rotation of where the ledge is facing, but that didn't really worked well. So I opt by using this by tags because I have more consistent results without having any bugs. So it's 100% sure that if you use the ledge stripes and the tags correctly, you don't have any bugs, basically. Love your content. Where are you from? I'm from Brazil. I'm Brazilian. So here you get the hang trace. We get the break hit results so that we can access what's in the structure. Now, of course, you can also do this. You can get the hang trace and click here on split structure so that you can access all the content into that from that structure. So as you can see, you have a lot of options to get which information you want to get. You can just get it from here. Of course, you can do it this way, or you can just break the hit result. It doesn't really matter. But I like to use the break hit result because it's much more simpler. It gets to be more organized because you can collapse the thing in here. All right, so we're going to get the tags out of the hit actor. We're going to get the reference. So there is two gets, one for getting a copy and getting a reference. I think both works. I'm not sure about the difference, but I think get a copy works very good. So here you're going to use two nodes, one for converting into a float. So actually it's to a string. So here you're going to use toString and then toFloat, string to float, and then finally you're going to make a literal float. Actually, you don't need to make a literal float anyway, so you can just go to outputs and there you go. So you're going to go to the ledge angle, you're going to execute it so that the character can know which direction he should face at. And there you go. All right, so once the character is rotated to face the ledge, we calculate both the current and target positions to correctly align the character onto the ledge. So these calculations are for calculating here with the timeline which location and target location the character should be set to be at. And there you go. I think we also set this, so set actor rotation. I think I'm just missing one calculation here. Yeah, so this code in here, it prevents bugs. Especially orientation bugs. It's very important. Let me just see something here. No. Yeah. So without this important code, yeah, I'm going to show you before and after, and I'm not going to say anything. Just watch. Without this code, the character, if you go to this angle, the character goes through the block. Now with this code, so it pretty much prevents the orientation bugs. And it's very important. So what happens here is that when we execute a location correction, we firstly need to set the actor's rotation to where it should be, so that we can have a precision calculation of placing the location of the actor. So as you can see, the character is aiming this way, but he wants to attach on this ledge. So if we just set the rotation of the character right away to where the character needs to be at, we just need to now move the character to its position. So we just need to move the character forward. So in the code, we have the calculation for moving the character forward. So let's say, hey, this is get the current actor forward. I don't know, location. Get the current location, the current forward position here. So we have the code for calculating, for basically moving the character forward. And then we also have the calculation for moving the character's location to the left. So we firstly run the calculation for the character to go for the left. So we run the calculation for going 90 degrees. So after the character has gone to that direction, we calculate the character to go forward. But if the so that works. So if the character, basically the character is going to go to the left first, and then he's going to move forward. But what happens if the character runs the location first and then the rotation? So what's going to happen is that the character is going to move forward. So instead of going here, the character is going to go forward, and then he's going to go left. So instead of going to the ledge, he's going to go right to the other side. He's going to go not to the ledge direction, to the ledge destination. He's going to go to the right. So that's very important to know. I literally spent a lot of time trying to figure it out, but then I finally found a solution. Going to game. My question is: a new game dev, is it okay to watch free courses online on YouTube? Yeah, it's okay. I think online courses doesn't, especially for blueprints. I think the correct way would be to watch on Udemy, because it gives you more precise answers. I think buying a course on Udemy, it's much more worth it. Yeah, it's totally okay to watch a video and do it by yourself, because you're going to understand the process of how to do a certain thing. But it's much more easier for you to try to when you make a tutorial, when you make a project from a video, from a tutorial, try to change the settings, try to implement something, try to change some values and see how it works. I think that helps a lot. I've done that in the beginning when I was just starting, and it worked. So here we're going to calculate the current location and the target location so that we can know how we should move the character from point A to point B. So here, for making the calculation for the target location on the ledge, basically that's the calculation for moving the character. We have a specific offset of how much the character should be placed forward and backwards. So here on this value called init ledge forward offset, we can change the forward offset so that the character can be too much forward or backwards, depending on like which character scale you have. What's the size? Maybe the size of the hands also matter. So here you can change the forward offset, and here you can change the vertical offset, how much down or up you want your character to be on the ledge. So let's change this value here. Let's change this value here first, so that I can understand how it works. So here right now is 38. Let's put it to be 90, so you can see the difference. So when you first attach on the ledge, as you can see, the character is going to be too much backwards. If you put it to be just 1 or 2, as you can see, the character is going to be too much in the ledge. So that's going to be the value that I can add at the forward offset, and here's the vertical offset. Right now it's -18. If you change it to be like 60, the character is going to be too much down. Anyways, now you know. Now you can change these values to see which one works the best. So only use this calculation if the character is already facing the ledge. Otherwise, it may cause an incorrect forward offset or similar bugs when snapping the character to the target location. All right. So here we get the hang trace. So we get the impact point, which is where the trace is. We get the forward vector to calculate how much forward the character should be at. Here we use a ABS to basically convert. If this is a negative value, we should convert it to be positive. I'm not sure why I've done this code. I don't remember exactly why I've done it. When you can just do this and then set it to be maybe -38. I think that's what was the code before. I think you don't really need this code. You just plug this in here as it is in this one. So -38. Yeah. There you go. Now when you firstly attach on the ledge, it's gonna work. So yeah, that's a perfect code that I've made. Just enjoy it. Hey, can you show how to implement slide using PSS and PSD? What is that, PSS and PSD? So here we update some timelines. Here, it basically pretty much resets the timeline state, location, and rotation to prevent desynchronization or repeated execution bugs. Because when you're running a timeline for the first time, you want to know when the timeline has finished or when it has started. So this is just a way of making the code to pretty much tell the code that the timeline has just started. And here we play from start, the location and rotation timelines. So here we have the timelines. For making the timelines, it's pretty much simple. I'm gonna do one from scratch so that you can understand how you can do one. So here you can click on add and then timeline. And then here you can choose what's the name of the timeline that you should be set to, or let's say location, timeline, character, for example. So you're going to double click on that timeline. You're going to add a track, add a new track, add a flow track. And then here you can choose a track name. I don't know, alpha. The length is like how much seconds you want the character to attach on the ledge. Like how fast you want the character to attach on the ledge. I like to choose a value between like 20 milliseconds or 30 milliseconds. I think I'm gonna do 22 milliseconds because that's the value I've chosen to be before. Now in here, you're gonna have to make a linear curve. So how can you do that? So here you can right click, you can add a key through here on this option, or you can just hold shift, left shift and left mouse button, left mouse click to add a new point. So you need to add 2 points to make a linear curve. So you're going to do once more. And then here for the first key, for the time, we're going to choose it to be 0, and the value is going to be 0 because you're just starting out. And then in here, the time is going to be 22 milliseconds, and the value is always going to be 1. So you can press F to just zoom in here, and as you can see, if you click on this key, you can see the time and the value. And then here, you can see that the time is 22 milliseconds and the value is 1. We use the value 1 because we use a specific function that requires a value from 0 to 1, which is this one over here. Let me show you. So this is the function. The function name is going to be called Lerp vector, and then it lerps one value to the other. So it lerps from the point A to the point B, and it requires the alpha value. So if the value is 0, then it's going to be A. So that if the value is 1, then the value is going to be B. So if the value is like if the value is like 0.5, now this Lerp vector here function is going to basically calculate the medium distance between A and B. And if this value is set at runtime from slowly going from 0 to 1, then the character is going to go slowly from point A to point B, right? So you pretty much define how fast the character should go from one point to the other. So let me just give an example here. Let's go to the event graph. And here on the event tick, I put this Lerp vector. At the beginning, when I was learning how to Lerp values was very difficult because I found very little tutorials that could explain it well. And I think one good way to explain how this Lerp vector works is by making calculations like this, for example. So here on the event tick, which if you print a string and press play, as you can see, it's going to print a lot of strings because it's executing at the runtime a lot of times. If you just put this value, yeah, let me just reset everything. Alpha 0, B0, A0. So just click on play. So as you can see, it's all 0. But now if the A is, let's say if the A is 0 and the B is 10, and press on play. Now, as you can see, the X, Y, Z are zeroed out because the alpha is 0. But if the alpha is 1, then we're going to get 0, 0, and then 10. So watch. So as you can see, it's 10 now because we just moved from 0, which was the state of being here. Yeah, I'm not sure how to explain this well, but it just works. So if you set the alpha 1, it gets the value of B. If you set the alpha 0, it gets the value of A, which is 0. If you get the value, the halfway between them, like 0.5, for example, you get 5, right? So if you use that to translate the character from going to point A to point B, you get the medium result. Yeah, so that's pretty much it. If you want, you can split the structure, and as you're only working with the Z value, you can just print the string, print the value of Z, and then you get 5. So if you set it to be 100 in here, you're going to get 50. Let's say if the alpha value is like 0.2, so it's going to get 20, right? So if you just get the actor location and then get where the character should be at, and then set the alpha to be 1. As you can see, the character is going to move to B. So if I just want to get halfway, yeah, that's the worst example possible, but I hopefully you could understand this one. All right, so what we're going to do here is just basically simple. We're going to set the actor location, and we're going to get the Lerp vector. So here, as we've calculated the current location, we're going to get the current location variable, and we're going to also get the target location. So as we have as the current location is the starting point, we connect it to A, because A is always the starting point, and the B is the end point, is the target point where the character should be positioned at, which is the target location. So we connect it to there, and then we connect it into the return value is going to be connected to the new location, which is going to be set through the setActualLocation function. So if I were just yeah, I cannot test this right now, but if you're going to understand how it works. So all you got to do now is just play from start. The way I got this variable was just by getting the name of the timeline. So you can get the name and then get the name of the timeline. So get location timeline character. As you can see, you can just drag out of this and get the play from start. As you can see. And then there you go. So you can play. And then get the character to attach on the ledge. Okay. Of course, you need to set other values, but that's essentially it. Actually, you don't even need the rotation timeline. The rotation timeline, because you already rotate the character through here. So I think it's not really needed. So all you gotta do now is just reset the value. So CanAttachToLedge back to, we set this to be finished so that we can move the character. We can delete this. Delete all this. I don't need this. There you go. So press on play. What's going on? Oh yeah. As that timeline was also referenced there, I'm gonna have to change the references. So just get the timeline name, stop, and then connect it to here. So when we detach the character, we need to make sure that we stop the timeline, because if we detach the character without stopping the timeline, if the timeline is still running, we're gonna have some issues. We're gonna have some glitches. That the character is just going to be fluctuating the air. All right, so as you can see, it's working. Now, of course, if you change the timing here, like how long it takes for the character to attach and position itself on the ledge, let's say 2 seconds. And then if you change the endpoint of the timeline to be 2 seconds as well, as you can see, if you press on play and then attach on the ledge, so as you can see, it's going to take 2 seconds for the character to attach on the ledge. As you can see, it takes 2 seconds. All right, so that way you can understand how timeline works, how timelines work, and how the Lerp vector works. Sorry for that. So if you don't, let me just change these values back to 22 milliseconds, or maybe 25. If you don't, after the timeline finishes, we need to set these values back to true, so that we can make sure that the character can attach to the ledge and can process the input. So if you don't do that, as you can see, if I keep pressing F, the character is not going to be able to detach. So I need to do this. So when the timeline is run, it's going to do its job. It's going to move the character to its position and blah, blah, blah. What else do I have here? All right, so this part is done. We could explain everything, how the attachment code works. Now we're going to go for the detachment part. I think that's going to be a lot easier to understand. So for the detachment part, we check if the character is already climbing on the ledge, which is going to be true if the character is already climbing. There we go. Let me see. So when you press F, as you can see, this variable is going to be true if the character is already climbing. And then this one is going to stop the active ledge transition, timelines, location, and rotation. Actually, this one is not only this is only location now because we deleted the other one to prevent one unwanted movement after the player detaches. So this is just going to make sure that the timeline stops running if in case it's running. And in here we run a montage stop. This is good for specifying. Yeah, I'm not sure why that happened. Let me see. Oh yeah, I think the tag name was 0. Actually, we don't have tags in here, so let's set it to be 0. So this one is 0, 0, and this one is 0. That's why I had that bug, I think. I just got an error here. Attempted to access index 0 from array of length 0, but then it didn't have a tag, but now it does. So this is how fast the animation goes from one pose to the other, because we have a blend time that we can specify to give it so that the character can smoothly detach on the ledge to go from pose 1 to pose to A pose to pose B, to go from one pose to another. I think that's better. So you have a specific blend time that makes the character to go from one pose to the other. So for example, right here, I'm gonna do it slow motion. If you press F, as you can see, that takes that was supposed to take like 25 milliseconds, but I think that's less. And the reason why I think that's less, because the blend poses by Bool also decides how fast the character should go from one pose to the other. So as you can see, if you debug this and go to, I'll just expand this a little bit. So when you go from here, as you can see, I'm gonna do it slow motion now. Pay attention to the blend poses by Bool, how it's going to change it. So when I go F, as you can see, the blend poses by Bool also decides how fast the character should go from one pose to the other. So we have the true pose and the false pose. So it decides pretty much how long that should take. Now, I think I should set the false blend time to be .25. I think that's going to be a lot smoother. The character is going to detach a lot smoother on the ledge. So when you click on, as you can see now, that's going to take 25 milliseconds. So as you can see, yeah, I think that's a lot smoother now. But the montage stop also going to help, but this is going to decide more how fast the character should blend. All right, so when we stop the montage from playing, if we have any montage playing, we prepare the character movement for detaching, so we can set it to falling. I usually don't set to walking because only if the character is already on the ground, as you can see. It works the same, but I think falling works best. We have better transitions. We reset the collision enabled back to capsule and mesh for the capsule and mesh. We set the ledge navigation timeline finished, and we set all those variables to back to where they should be. So that's the detach code. It's a lot simpler. All right, so now that we've learned how to attach the character, yeah, I'm not sure why that's going on. I'm not sure. What? Is it because of the code that I've deleted? Attach location. Maybe it's because of the code that I've deleted in here. Absolute float. I'm not sure. Yeah, I think the rotation timeline is also needed in this case. Rotation timeline. So we're just going to do it real quick. Ledge. Now I don't remember how I've done it. We're going to get the current, get ledge angle. And here you're going to get the Lerp rotation, Lerp rotator. So to make the rotation timeline is very simple. You're just going to duplicate from the timeline that we just made. We're going to set the active rotation. We're going to get the current ledge angle just for the Z because we're just going to move the character on the Z axis. We're going to get the active rotation, but I think this one should be not on this because we're moving the current character's rotation from A to B. So the A should always be the initial location of rotation of where you should want an actor to move. And the B should always be the target destination. So we're going to get the current ledge angle, which is, we're just basically reading what which location the character should be facing at. And I think that should be done. That's going to be it. Now I'm going to press on play. It's going to also work. I think that's a lot more safer to also execute the timeline, because sometimes the character should... that's going to just basically force the character a little bit to move and face the ledge. That's going to force him to face in case anything happens. And that's going to be a lot safer to execute this way. So yeah. I think we're not going to need the finished for this one, because we're basically using the same values. So it's 22 milliseconds for this one, actually 25 milliseconds for this one, and for this one as well. So that should be it. Now we're going to go into moving the character on the ledges. Now that I've finished the attachment on the ledge, attachment and detachment, we're going to work on the ledge navigation system, which is this one. So you can press left, right to move the character. So you can press left or right to move the character on the ledge. So let's do that right now. Oh yeah, and also if you get your gamepad controller, you can also move the character. So let me just get mine in here. You can also move the character. So as you can see, I'm moving with my gamepad. So you can move pretty much the character in any direction. It also works with the gamepad, so that's good. Yeah, let me show you a project that this is the premium one. If you get the character, you can also see how it works. Hopefully the stream is not going to lag a lot. So this is the complete system, complete and advanced system that we have. So you can climb on top, climb down, drop, climb up. You can also do corners. You can also do inner corners. Without any bugs. You can also do freehang. You can also climb on top. And this is not done yet because you also have some bugs, as you can see. The character snaps sometimes. Freehang. You also have the leap 180. Hmm. There we go. Now here for the movement input, you're going to promote the action value. So this action value pretty much tells you which direction the player is moving which direction the player wants to move the character. So if you press W, essentially you're telling the code to move forward. If you're pressing S, then you want the character to move backwards, something like this. But of course, that's going to depend on the perspective and if the character is strafing or not. So essentially, that's what it does. So we have this vector, which is a 2D. So you pretty much, for the action value, if you break in here, the vector. So I think the X should tell you, if the X is +1, it should tell that you're pressing W to move forward. If it's -1, then it tells that we want to move backwards or to the left. So if the number is negative, it should be the player wants to move either left or backwards. If the number is positive, then the player wants to move forward or to the right. That's essentially it. So we're going to promote it to a variable because we're going to be using it later. We plug in the cancelled and completed actions as well because we want to know if the player has released one of the keys as well. Here we create a macro called action values management macro. And this one, we have 2 execution inputs in here. So it's called triggered and cancelled or completed. So we treat each case differently. So here for the inputs of this macro, you can of course create a macro by clicking here on macro, add a new one. Triggered. So here you can add a new input if you want to and choose execution, rename it. So we're going to block the inputs if false. Here we validate the values. This blueprint checks if the player can move. If not, it forces movement inputs to 0. If yes, it reads the real inputs, stores them, then rechecks them. There we go. So here it promotes it to a variable. So maybe here you can just take a screenshot because I'm not sure how I've done this. I just made it to work. I don't really remember what I've done and why I've done this, but essentially we're just promoting values and we're just resetting them to 0 if the player is not pressing any key. And here for the X, at least we're just routing up some values so that we can use it for the trace later. So then we connect it to outputs, and then we move to the next validation check, which is to check if the character is already climbing on the ledge, because if the character is not climbing on the ledge, then we were going to run the default movement, which is this one right here. So if the player is not climbing on the ledge, we're going to use this default. So if the player is going to be climbing on the ledge, if the player is climbing on the ledge, and press F, as you can see, and try to move, as you can see, now we run the ledge detection. And if the ledge detection detects a ledge, then we're going to go to the next step, which is the ledge climb movement. So as you can see, if you go up, it detects. So let me just explain you real quick how I've done this ledge trace detection function. So here we perform a trace in the direction the player is aiming. The 2D navigation up, down, left, right. So here we run a capsule trace for objects, which is the capsule that you see right over there. So here the radius is 30, the half height is 40. You can pretty much change those values later. Now, what I want to do is just place that, what I think is happening here. The trace is a little bit up. I think I wanted to place a little bit down. Maybe the Z offset, you can change it here. So as you can see, the capsule is too much up when you aim to the left. So yeah, this is going to be a mess to explain, but essentially what it's doing here is basically reading from the player's input. So based on where the player aims, we can place the ledge on that location. So if the player aims to the left, we position the trace to the left. If the player is aiming to the left and up, we add up that value vertically. Yeah, this is it requires a little, to explain this, it requires a big brain to explain. So essentially that's the code for doing it. Here we have the start location and end location. Of course, we make the ledge to be detected for the object type. And here we control the up vector. And this is also work in progress, so I think it's not really worth it to explain everything right now, because it's going to be changed. Now, I think a better way to do this would be using a multi-capsule trace for objects and then detect every single... Yeah, but I think that's not... Yeah, I'm not sure if I should do this. I think there is a lot of ways you can do things. And sometimes doing the basic is what works instead of just complicating things and not making it work. I've gone through that a lot. Now, if the capsule trace hits an object, then we go to branch, we get to true, and then we set the ledge hit detector to true. And then we promoted the values of the hit structure of the ledge. So we basically get those values later. We retrieve it from the... We just save those values to be read later in the code. And then we just plug the ledge hit detector to the return node so that we can read it after. Condition. And then we go to the ledge climb movement. All right, so basically what's happening here, if I just unplug that, yeah, it's not going to happen anything. So when we move up, we detect. The ledge trace detection gets to be in here, detect, so that we can move to the next step. So the next step, it's a lot more than you think. So here you check firstly if the character is already climbing on the ledge, again, to prevent bugs. As you can see, when I click here to move in any ledge, as you can see, it goes to here. It checks if the ledge navigation timeline has finished, and then only continue if player is pressing any key. I'm not sure why I set this value to be 1. Save custom inputs value if it has an input. I'm not sure if you change it to 0, I'm not sure what happens. Yeah, I'm not sure. Let me just set it to be 1. Let it to be set to 1 because I'm not sure. Maybe this is a mistake by me. Anyways, so we save an update inputs. if we don't do this and press play, nothing happens, I think. I think it's good to have it. So check if the ledge got hit. And then here we gather and process all ledge related data, impact point, target transform, angle, reach distance for use in movement, and transition calculations. So after the ledge is detected, we run a series of checks. So firstly, we check for the target data. Essentially, we're going to check what is the direction that the character should face on the ledge, what is the where exactly the sphere trace has hit on the ledge, what is the tag that is attached, that is assigned on the ledge, what else? The angle difference between the character and the ledge. And then here we determine the ledge direction and the ledge montage selector by enumeration, and then we have all this. So let's go first with the process ledge target data. So first of all, we get the current location of where the character is, which is very important as well. So here define the character center point, so it can serve as the base for calculation and for comparisons with subsequent target points. So the reason why I'm doing this is because let's suppose the character is right over here, and then when you get the actor, when you get this node called actor location, we essentially get the actor's location point. But as the character is on the ledge, let's say the ledge is right over here. So let's say his hands are like over here, and then let's say the ledge is right over here, right? So we need to decide where we should consider the center point of the character, because if you only get the actor location, it's going to get the pelvis location. So imagine you get the actor's location center, you get this node called get actor location, and then now you need to go to the next ledge, which is this one right here. Now, and then there is this one, and then there is this one, let's suppose. Now, if you just get the actor location, if you go to this ledge right here, and then let's say the ledge trace detected this point, as you can see, right over here, to the same point. Now, if we would define the center point to be right over here, right in the neck, as you can see, the angle is much more different. Now, the angle, instead of being like, I don't know, 30 degrees to the right, it's now 20 degrees to the right. So that pretty much tells the difference, that pretty much tells which exact animation you should be playing. Because I think it makes more sense to just define the center of where the character location is right in the neck, so that we can have a better precision choice of where the character should be moving at. Now, maybe that doesn't make sense, but I think it makes sense for me while I was testing new animations, and I found out that the best calculation would be this one, calculating from the neck and a little bit forward, because if you take a look at the right side of the character, when the character is on the ledge, like right over here with his hands, if we just get the actor's location, we would get the pelvis location, so the character, the center point would be right over here, and the ledge would be right over here. So we have a forward offset as well, instead of just, if you just place the center, if you consider the center point to be right where his hands are, regarding the forward offset, if you just get the same forward offset as where his hands are, we can have a better idea and better calculation of placing the character where he should be. I think that makes sense. So that's pretty much what I'm doing right now. So here we calculate the ledge target end, and then here we have the dynamic ledge attachment, impact point, and then this goes to pretty much saves the location of where the capsule has detected the ledge. Here you have the reach distance, the difference of the distance between the character and the ledge. And then we save that distance. That's going to be later used for deciding which animation we should play, because we have a lot of animations. So in total, if you have to have an idea, we have different directions. So we can go to the left, diagonal left, up, right, left. So right, down. So I think at least we have 8 animations, 8 different directions that the character can go. Multiplied by the distance. So we have different distances. I think we have short, medium, and long distances. So multiplied by 3. So in total, we have 24 animations to be played, and we also have variations of those animations. So I think it could be multiplied up to, I don't know, 48 plus animations. So we're going to place all those animations in there. Here we determine the target ledge angle based on which angle it is that the character is going to be attaching to. There is the code. Here we select the forward offset. So if you want to change this value here as well, you can be free to change. So if you change this value, instead of 38, you could put 90. So when the character attaches to moves on the ledge and then goes to the next ledge, as you can see, changes the forward offset. So just choose the right value that matches up with your character scale. Same thing for the vertical offset. So basically we're just basically choosing a different offset depending on the character scale. So after calculating which location the character should be and which rotation the character should face at, we define the target transform, which gets all those values, both the location and rotation, and save it. Here we define the target angle difference. This is used for corner calculations, because when you're, imagine that this is right over here. I'm not sure if this is the angle difference regarding if we should, depending if you have like an angle right over here. Because if you have like a ledge right like this, tilted, maybe, I'm not sure if that's the code part that does that. I'm not sure, but in the premium version, I think, as you can see, we have a tilted ledge like this. And then when you press play, the character changes and it's rotated to that direction. So as you can see, the hands are perfectly attached, even when you go down. All right, so here we calculate the target angle difference. If you change this value, for example, here, when you try to move, as you can see, it doesn't work. So we make the transform actor center location plus actor rotation, find the angle between character center and hit ledge target location, get forward vector to compare. We use Y for X and Z for Y because of the three-dimensional perspective angle. Yeah. So we find the delta between the current and target angle. And then here we choose the current ledge angle for the A and targeted ledge angle for the Z. To calculate the rotation difference. And check if the last ledge target angle was the same. But I think this code is not really used. So we just promote to a variable. Before I had a code that would calculate if it was the same. So in here, after calculating the process, after processing the ledge target data, we move on to the next step, which is resolving the final ledge movement direction based on leap checks, corner detection, and player input, returning the appropriate enumeration for execution. So here you're going to determine the ledge direction, like how much time for, okay, it's 2 hours live stream. Already, wow, 2 hours. So here determine the ledge direction. So this function is responsible for deciding the final ledge movement transition direction based on the player's input and special cases. This is so this function is responsible for deciding the final ledge movement transition, this direction, based on ledge target data. So here we have this enumeration, and this enumeration, it pretty much decides where the character should go. So you should have that enumeration here. To create one is just go to here, create enumeration, and then you're going to add the enumerator, you're going to add the values. So here for the first value, it's going to be up, right down, down. And here you can choose the not set up one, because there might be cases that the trace does not detect anything. It doesn't really know where to go, where the character should go. So not set up is the way to tell the code that, hey, we haven't detected the direction that the character, we haven't detected the proper direction that the character should go to, so we just set it to be not set up. All right. So for the next step, so here the ledge input parameter pretty much tells you where the direction of the character should go. So when you press on play here, when you go up, as you can see, this is executed, and then the function is finished. So when we have the return node in here, that pretty much tells that the code that the function should be finished. So when you go down, as you can see, this one down below here is executed. All right. So here, I found these values to be like this. So the X minimum is -0.3. All these values here I found by myself by just testing new stuff. So I just found the right values and what they mean based from this calculation here, from the rotation. So we're basically getting the difference of rotation to calculate which direction we should go based from that. So we create a macro called LedgeInputParameter, and then we have this code inside. And then if the code is if the X value is between -3 to +3, and the minimum of Y is 0.8 and the max is 1, that means that the character should be going to the up, right? That's a little bit crazy to explain, but that's the way it works. So if those values are in those ranges, then it should go up. Then we have those values that means that the character should go down. And then this is right up, and this is right. This is for going down. This is for going left down. And if it's false, then that means that the character hasn't found a valid direction. So we set the enumeration not set up, and we want to untick this option here. So that's pretty much it. Let's go for the next one. So if we determined a valid ledge direction, if we haven't determined, then we set it to be, say something like, I don't know, ledge direction invalid ledge direction, something like this, so that we know if the ledge direction is valid or not. So for the next step, after processing the ledge target data, after determining where the character should go based from the ledge directional values, we go to the next step, which is choosing which montage we should play based on the direction that the character is going, and at which distance, which exact montage based on the distance and direction the character should go. So here we select and configure the appropriate ledge transition montage, animation, play rate, offsets, and timeline. Angle, distance, and transition type, leap, corner, or freehang, blah, blah, blah. Now, inside this coding here, we have just this code. But if you take a look at the advanced what I have prepared for premium members, we have this code over here. So we have this much for calculating, for basically choosing, because of course we also have the inner corner, the outer corner, and we should have much more for deciding where the character should go. I think I could just collapse everything into a data table, a table chooser, or choose a table to basically calculate this better, so that we can basically choose the montage based on some parameters, some values, right? So for now, we just, on this code, as we can only move up, and we're using short distances, and we can only move up, down, left, or right. We only have this part of the code, which is pretty simple to understand. So here we reset this value so that it prevents from the latest animation from playing. So here we have a sequence so that it's easier for us to just end the montage and the function. So then 0, we have a branch, and then it checks for the angle. So this angle right here is the angle that it checks for the angle for this one. So if you have this angle like this. Oh yeah, I forgot to also change the tag. That's why. So for example, right over here, if you just rotate it to here, I think it's negative, maybe negative 10 or positive 10. And then here, maybe it is, maybe here is positive 10 and maybe here is negative 20. Yeah, maybe here is 10 as well, negative 10. There we go. So if the ledge is too much over here, maybe 40, I think it's not gonna go there, as you can see, because it's not between those angles. As you can see, it's not between these angles here, but the reach distance, this one checks for the direction and the reach distance. So when you move like this up, it already detects that the character is moving up. So we go to the up one in here. So it pretty much checks if it's between the reach distance allowed. So as you can see, it is allowed, but in here we also check for the angle, which the left and right angle. So you can also change it here. So let's say negative 50 or positive 50. And then if you go to that angle, and then you go to that angle and then do this, as you can see, the character is going to attach to that angle. But I think it pretty much depends on which animations you have. Maybe you're gonna have to have a specific animation from going to that angle. But anyways, let's just delete this. Now here we selected the montage based on the enumeration value. So here we get the, of course, you're gonna have to create the enumeration. After you create the enumeration, you're going to set the variable type to be montage enumeration. So you're going to select it here, name it. Oops. And then in here, we're going to basically select the montage, have the selection node, and then put this right over here. And then in here, we're going to select which animation you want to play based on the direction that you want to go. So here, if the character is going up, we're going to select the animation of going up, which is this one. And remember that we have to set the group to be LedgeSlot so that we can have a better, so that the animation can be executed in the backend, in the animation blueprint. That's all you got to do in here. Just make sure it's connected. And there we go. Now in here we set the ledge parameters for angle, from angle. I'm not sure if in this, oh yeah, we were using motion warping, so that's good. So before I was using timelines. So I used to have this use saved active transform in here, which is not going to be really needed for now. But as you can see inside of this function, I have this one, set ledge parameters from angle. So I have the delay until correction, play rate, starting position, and so much more. So don't move if player. Don't move the player if no valid direction was found. We're going to use motion warping to correct the character's position on the ledge. So all you gotta do is just click here on right click, go to the montage of the player, of the character going into the ledge that you want. And then on the notifies, go to 1. And then right click, add notify state and montage, motion warping. So click here on motion warping. And then you're going to have this window. On this window, you're going to choose a warp target name. I've chose mine to be ledge warp. We're going to use these values in here. Warp rotation. Don't ignore the z-axis. And you can choose these values. And here, it's very important to choose the motion warping to be where it should be. So the motion warping in this case, when the character goes up, as you can see, we have the root bone, which starts over here, as you can see. And then when it goes up, it goes up, it goes up. And then at this point, at the middle of the motion, we set the starting point in here so that the character can correct its position later. And then at the end, where the root bone reaches its final destination, the motion warping has to stop. So we just let it to be running a little bit more, and then we stop we place the endpoint. Now we're gonna have to do this with all the animations that the character goes into different directions. And boom, there we go. Now here now what we're gonna do, if you don't have the motion warping component, we're gonna have to add one. So motion warping, add. In here, get the motion warping. What else? We get the add or update warp target, as we've done in this case. Here on the warp target, what you're going to do to get the little window in here, we're going to make motion warping target. So you can have the So you can have the options to place in here. So as you can see, I have a different offset because it's required. I get the target transform, location or rotation. For the location, I add a little bit of offset for subtracting 87.5. If I put it to be like 1, oops. And then I try to play, as you can see, the character is gonna have a different offset when I go up, as you can see. When I go up, that's too much. Wait, what's going on? Oh yeah, because the name in here, oops. I haven't specified the name. So the ledge warp. So make sure that the warp target name is the same so that it works. So when you press on play, now the motion warp is going to work. If you set it to be 1 in here, as you can see, the character is not going to be in the right location. Yeah, that's pretty much it. On the component here, I like to set the capsule component to be set in there. And for the play montage, we get those parameters, play rate, starting position. Here is the wait time until allowing the character to go to the next ledge. Now this is still work in progress because I don't really know when we're gonna have to set this up later. But for now, I just choose a retrievable delay so the duration is 0.7 65. You can change it to be 1, for example, but if you try to go to the next ledge, as you can see, the character is going to be like this. It's going to be more responsive if you set it to be 0.1, 1 millisecond, but I don't recommend it because it allows the player to spam. So I just give it a little bit of time until we can go and we can allow the player to go to the next ledge. We just block the inputs, basically. And then here, after this delay, we update the ledge angle variable, which means that when you go to the next ledge, maybe the angle is different, so we just update it. So update the boolean variable that the ledge navigation timeline is finished, or the movement of the character on the ledge has finished. Yeah, so I guess that's going to be it for this tutorial. It just it's not actually a tutorial, it's just more of a code explanation of what I've done to achieve this ledge navigation movement system. All right, so that's going to be it. I guess there's nothing more to explain. Just be sure to place such values such as this one, CanProcessInput when the character is crouching. Just place this branch into here on the crouch inputs. For the aiming as well, it's very important to set this up. If the character is already climbing a ledge, for example, don't allow the character to crouch, the player to make the character to crouch. So if the character is climbing on the ledge, don't do anything. For strafing as well, I think this is toggle. Oops. So if the character is not climbing on the ledge, we can strafe. All right, so I think that's going to be it for this code explanation. And thank you guys very much for watching. And I see you in the next one. And I see you in the next one. I think there's not much things to explain right now. I think I've just went through everything. I plan to expand this system much more. Yeah, so that's it.